Hello everyone. In this video, we will be discussing the forces acting on object or a group of objects moving as one system. So the scenario I have here with this question, I have two blocks. One of them sitting on a table horizontally, and the other one is hanging vertically with the same rope. The rope and the pulley, both of them massless, frictionless, so we don't need to worry about their values or like the mass or the friction generated because of the pulley at all in the scenario of this question. Now, within the answer of this question, also we will be discussing the free body diagram, which is labeling and identifying all the forces acting on every single object within the system. So I have two scenarios in this question. The first one saying consider the system of two masses as shown. Find the acceleration of the two masses for the following two situations. So in both cases or both scenarios, I will be calculating the acceleration of the system, which will be the same acceleration for two blocks because they're moving together. First, when the table is frictionless. Second scenario is when there is a friction on the table, and because of the motion, it will be a kinetic coefficient friction is given as 2. So let's start with the first part. And as a start, I will be identifying, or as I said, doing the free body diagram. For block 1, I will have the M1G. I will have the normal force, and definitely we have the tension on the rope. Now for block 2, I will have M2G, and I will have also the tension. There is no need to call it T1 and T2 because it's the same rope generating the tension on each block, so it's the tension. Now the way we handle part A, I can say, all right, object or for mass 1, the total forces acting on that mass will equal m1a. That's from second Newton's law. Now when I look to block 1, I will say, okay, what forces acting on this object on the x-axis or causing the motion? I will find only the tension equal m1a. So that will be my first equation. Okay, let's go to for block 2. Same, the total forces acting on it, but this time it's m2a. Now we will consider the motion to be this way. So anything going this way, that will be a positive acceleration, assuming the second block will be pulling the first block. Now that will make m2g minus tension equal the second mass multiplied by acceleration. Great. That will be my second equation. Now, when I look to the first equation and second equation, I will notice that the tension is the common thing between them, or the common item between the two equations. So let's put the two equations on top of each other. T equal m1a, here is m2g minus t equal m2a. Great. Now, if I'm gonna do the addition or combine these two equations, that makes the tension will be canceling each other, and I will end with m2g equal m1 plus m2. Then the acceleration will be the common factor, because as I mentioned before, the whole system, the two blocks, because they are connected together, with the same rope, they will be moving as one object, so they will have the same acceleration. Now to calculate the acceleration, it's simply going to be m2g over the combination of m1 and m2. Now let's do some calculation here. It's divided on 7. That will give us 2.8 meter per second square. That will be the acceleration of this system without the friction on the table. Okay. Of course, we can calculate the tension now by simply just replacing the 2.8 on equation 1 or equation 2. Obviously, it's much easier to use equation 1, and then we can find how much is the tension. But this is not what we need from this example. Okay, now the second scenario, which is having a friction on the table. So let's see how that will change the acceleration and how is that going to change the way we handle the scenario. All right, it's the same thing. Let's do the free body diagram again. I will have a tension. I will have the normal force generated from the surface. I will have the m1g, and I will have here the kinetic friction, because it will be opposite to the direction. As we mentioned, anything goes this way, it will be a positive. Now for block 2, I will have again m2g, and here I will have the tension. Okay. Same way, I will say, okay, for m1, I will apply Newton's law, as I said, but this time the total forces acting on block 1 on the x-axis will be T minus the kinetic friction equal m1a. Great, that will be our first equation. Okay, now for m2, I will have m2g minus the tension, and that will equal m2a. That will be my second equation. Now again, the tension is the common item between the two equations, which means when I add the two equations together, the tension will be eliminated, and that will give me m2g minus the kinetic friction force equal m1 plus m2 multiplied by the acceleration. Okay, now from here, the acceleration equal the weight of the second mass minus the kinetic friction force divided on the combination of the two masses. Okay, now here we have to stop, because all elements, the mass, the second mass, the combination of the two masses, or the weight of the second mass, easy to calculate or find. The problem is going to be with the kinetic friction force. How can we calculate this? So we're going to stop here for a second. The kinetic friction force, we know it's calculated by the coefficients multiplied by the normal force. Now the coefficients, we know it's 2. The value is already being given from the question. So it's already 2, we know that. Now, how do we calculate the normal force? When we look to the system, we will see that the normal force located on the y-axis of the first object. So let's apply the total forces on the y-axis for object 1, and it will be m1a. However, we know for sure there is no motion on the y-axis, so that will make the acceleration 0, so this side of the equation will be 0. But what about what force is acting on the y-axis on object 1. It will be the normal force minus the m1g, that will equal 0. From here we can say, all right, the normal force simply equal the weight of the of the first object. So we can calculate that easily. It's 5 times 8. So this one here is 49 Newton. From here we can find, how much is the kinetic friction force by multiplying this by 2, and that will give me 98 Newton. Great. Now I do have how much is the kinetic friction force. I can replace it here and just do the calculation. So the second, we can do this one. We put all the numbers. 9.8 minus 98 and all divided by 7. That will make the acceleration. Let's do this one. That will give us a negative 11.2 meter per second square. That will be the acceleration of the system because of the friction. That's expected as the friction will generate kind of like a force against the motion. So it's the system is decelerating instead of just like accelerating. Okay? I hope you find this video useful, and I'll see you again with another one. Thank you.